Yeah, we are today working to continue on the project scheduling questions. I think last time I showed you the AOA and AON plots, and maybe I also showed the critical path and also the entire duration and the standard deviation. Did I go to that part already? Okay. So this time we are going to continue working on the problems and try to get the answers for the rest of the questions. So it includes the expected duration and the standard deviation, and we need to derive some probabilities, and using the probability, we are going to derive some financial indicators. All right, let me know if you have questions. Here I'm going to draw the diagram again so you know where we're at. Yes, it's either you're not really talking about I don't think there's I could do it, and I don't want to. Yeah. Right. Each was okay. Yeah. Are we all clear how we identify critical path here? Do you have any questions? Yeah. We have 10 minutes left. Then I'm going to show the answers to the question and also to show some additional techniques that we can use to derive inference about duration and in general random variables. So raise your hand if you have questions.
Fixed profit is 150,000 before. So then. Well, like, if it happens, we would only the beverage and top 50,000. So then that should be the answer. Oh, yeah. So in terms of technical path, there's times two possible. Whatever. Yeah, but there's only one also for the technical. The next one is just another thing about and so I think
This is a. I think it's like already. You have me feel it.
Then lost. I did like literally maximum like yeah, it's about yeah, get the blue it's like 3 months. Oh yeah. It's like 4%. Oh.
No.
If that ends up happening. So. Maybe not. Yeah. I mean, that's. Yeah.
There's AS, like your full area of field, not just every bar. Like you're gonna get up like 4 square, so there's gonna be 4 divided by and that's the amount of. But now it's like 1%. Then you first calculate now you go back to the calculate you bring up some values the first thing.
That's so silly. Yeah, but I mean, it's me.
Yeah, no.
Yeah.
Looks pretty good. Slightly different. I guess it's probably because the variances that you used is a different version. They might be too correct. Let me check. Actually use the same variance. Did you find the probabilities in the T table or did you calculate it yourself?
I calculated it.
Oh, okay. That should be pretty accurate. Yeah. This very slightly. Oh, wait.
Oh, I think we just rounded it.
I don't think rounding can create that much difference, though. Okay,
Oh.
maybe it's actually rounding because everything else looks pretty good.
Okay.
Yeah. Well. Cool. Any other teams that completed the questions? I think you are the winner again. So you can come to me after our lab and get all to this.
Okay, thank you so much. Yeah. Yeah. I think for next version, line 27. Are you saying this chart? There's when you're calculating, like, so then something got the big. Cost for the one. Oh, probability. Oh, okay, got it.
So this is like the
revenue minus the damage, then if we compare it with cost, which one is higher?
Oh, okay.
So each of us an idea, Norway, if we minus the cost that and the profit,
Okay.
then the profit is going to be comparable.
Okay.
All right.
Oh,
It appears we got a winner team already. Okay, let's get started to review what we need to address how we need to address these questions. Here I illustrated the both AOA and AON way of the diagrams. And to find the critical path, we need to calculate the expected duration. So recall that from PERT, we have this expected duration is going to be A plus 4 times M plus B divided by 6, right? So I used this formula to calculate each of these expected duration. And in some branching structures like this, we need to pick the longest activity. And here it appears that both C and D share the same expected duration, that's 10.17. So both of them, if we were asked which of them are on critical path, the answer is both of them are on critical path. However, notice that here, when I calculate the expected duration of the entire project, what I'm going to do is that I pick either one of the two to be calculated in the total duration, because during the same time, C and D can be completed, right? So they don't take the time one after another, but instead they can be done in parallel. So in that way, doing C while doing D doesn't cost another round of duration. That's why when calculating the total duration, although both C and D are on the critical path, only one of them is going to be accounted for in the total duration. So we use the same idea and we do the rest calculation. So in the total duration calculation, we have one of CD, then F, G, then only one of H and or I. The reason is again because activity H and I share the same expected duration, but they can be done in parallel. So both of them are on the critical path, but only one of them should be accounted in the total duration. And we do that for TJ, but here in this branching structure, we notice that L takes a longer duration than K. So when calculating total duration, we only include activity L, not K. And we do the rest. So we have this N, O, and P included. So here, my choice is that I included C and H. The choice here, whether you select C or D or H or I won't make a difference because they equal, right? But the choice makes a difference when we calculate the variance. So this variance again depends on which activities are on the critical path. So using the same idea, we are going to include only one of C or D in the critical path for the variance. Because the variance for activity C and D are different. Notice that activity C has a variance that's a quarter, but variance from activity D is 0.69. So here we need to make a choice. For example, in my worksheet, I picked activity C to be accounted for in the variance. So it's okay if you pick instead activity D when calculating variance. So in that way, you will have a different version of the total variance that I calculated. So using the same idea, we are going to make a choice between H and I. So when calculating H and I, notice that the variance for H is very small, whereas the variance for activity I is again a quarter. So depending on which of them you picked, your variance might be the same or different from what I calculated. Because there are two choices here, right? So 2 times 2, there are 4 possible ways to calculate the total variance. And all these 4 answers would be correct. So here I'm just going to make it simpler. So I calculate variance J, and there's also L, and M, N, O, and P. So in the last few activities, there are no choices we need to make. Instead, so here between C and D and H and I, there are 4 possible choices we need to make. So you can possibly get a result of 4 different variants. So here now you should understand how we can calculate the total duration and variance if we have branching structures, and also if we encounter some activities with the same expected duration. Any questions regarding these questions 4 and 5? When we calculate total duration and standard deviation. Any questions? Okay, good. Now let's move on to probability. Here, I think it's quite useful if I, okay. If I draw the diagrams of a normal distribution, so it should help us to understand how these probabilities are recognized visually. So we should be all very familiar with a bell curve representing a normal distribution. And all the calculation we just did there comes here. So this mu, the mean, is going to be our total duration. And the sum of the standard deviation comes here.
0, 0.
So the standard deviation is calculated as the square root of the sum of variance. So this is, total. And this would be also G total. And remember that when we sum, we need to sum the variance instead of summing any quantity like standard deviation. It'll be incorrect if we sum the standard deviations. Instead, we need to take the variance to calculate the total variance. Okay, now we need to find for question 6 the probability for a project to be completed within 85 days. We just calculated this quantity. That's let me take a look. It's 89.17. And the reference quantity is here. 85. 85 days is smaller than the mean or expected total duration, which means it's on the left side of the bell curve, which also means the probability that's calculated as the area under the curve is smaller than 0.5 because each half takes 1. Remember that we're calculating probability, and the probability for any continuous variable, or actually any random variable, needs to sum up to 1. So that's why on both sides of the bell curve, the area under the curve takes 1/2. And because this quantity is on the left side and it's away from the mean value. So the probability must be smaller than 0.5. And because we are calculating a probability, it's very important that we check the correctness. Using the Z table, of course, all the values according to a Z table, as an example you saw in our midterm, all the quantities of probabilities are between 0 and 1. But if you calculate using other sources, like a calculator, if you ever encounter that the result of a probability is, smaller than 0 or beyond 1, then you know that something went wrong. So you need to recheck and correct your result. Now, we need to find this area under the curve. I'm going to show very soon that we can do this in Excel. But now let's also see how we can calculate the second quantity. That's the probability of the project to be completed between 85 and 95 days. This 95 is on the right side of the curve. So our task is to calculate the area that's shaded by the horizontal lines. So using a Z table, we don't get this result directly because all the Z table only has one Z score, right? But instead here, it appears that we're calculating the probability between two Z scores. This can be done by recognizing that here, if I calculate a probability of this T between 85 and 95. This probability can be done in two steps. First, we calculate the probability that's the activity done within 95 days. So we calculate the left side of the right reference line. Then we are going to remove this shaded area to the left. That's by the tilted, that's shaded by the tilted lines. So that means we calculate this quantity by doing this. So first we calculate the probability that the entire project is done within 95 days. Then we calculate another probability that's it's done within 85 days. Then subtracting these two quantities, then that's how we get the probability that's a variable falls into this middle zone. Any questions regarding how we can calculate probabilities like this? All right, then, okay, question here. Yeah, so I just illustrated this step. Any questions here? Okay, now with this done, you should be, I think you should also have a sense how we can calculate the area that's to the right of it. In a Z table, we are always given to the area that's to the left side of the curve, right? If we are asked about the right side of the curve, of course, we need to make some adjustment by recognizing that the total area is 1, right? So using that knowledge, we can calculate the probability that this total duration is greater than 95. It's calculated by using 1 to minus the probability that the project is done within 95 days. Since we already calculated this one, so we just take the remainder from 1 using the probability of the project to be completed within 95 days. So this should give us an idea how we calculate all the probabilities. Okay, now with that in mind, you can get all the probabilities by looking into a Z table. And from this illustration, we know that if we want to know the area that's to the left side of the curve. If it's, for example, we calculated a z-score that's 0.22, then the left side of the curve has an area under the curve that's this quantity, 0.85, actually 0.89, 0.59 if we round it. We can find that this part is actually symmetric. If we go to instead not 0.22 but negative 0.22, like this quantity, we find that this area under the curve that corresponds to a z value that's negative 0.22, and the area that's positive 0.22, they sum to 1. So we can, if we are given only half of the z table, either the positive half or the negative half, we can derive the rest. So because the rest can be calculated as 1 minus the other side. Okay, any questions regarding how we calculate probabilities? All right, knowing that gives us a sense how these quantities make sense. However, let's also find out how we can calculate these quantities in Excel. I use the function called normal distribution. This function needs a supply of 4 arguments. First one is a quantile. Here, the quantile is the reference days that we need to account for. So for example, in question 6, when we are asked about the probability of completion within 85 days, this 85 is a quantile we need to supply into this function. So using 85, and we need to supply also the mean and standard deviation. We just calculated them here. So this mean is 85, well, 89.17, right? 89.17, and this variance, according to the choice I made, when including C and H in the calculation, but not D or I. This variance is going to be 11.31. So this standard deviation calculated would be 3.36. But there are 3 other versions of the standard deviation you could get. All these 4 are correct, because they depend on the choice you made here, which to include in the variance calculation. So using this formula, I supply the calculated mean and the standard deviation. I also give a true to let Excel understand that I want to calculate the cumulative probability. It just basically means probability because we are dealing with a continuous variable. So the result is somewhere around 10.8%. Did you get the same result? Any question here? All right. Using the same idea, I calculated this quantity. That's the probability between 85 and 95 days. As I just illustrated earlier, this quantity is calculated by taking a difference between 2 probabilities. The first probability we need to calculate is that the project is done within 95 days. Then we subtract another probability that the project is done within 85 days. So the difference between them is 85.1%. Any question here? Okay. Again, using the same idea, we use 1 to minus the probability that the project is done within 95 days. That's how we can calculate the probability that the project. I calculated this quantity for question 8. Using a formula that's 1 minus the probability that the project is done within 95 days. And the result is about 4%. So knowing all these probabilities are going to help us to give some financial indicators to the project. This is going to be useful if you ever need to manage construction projects. This might be a necessary project to evaluate the risk in the project. If we depend on the normal distribution, since we already calculated all the probabilities above, we use the result. So for question 8, if we need to address for question 9, when we are asked about the expected profit, we calculate this quantity using the probabilities we are given. So here we need to account for what the uncertainty comes from. The probability we calculated are regarding the entire project completion days, right? And there's a probability that we need more than 95 days to complete. And this is where the liquidated damage comes in, because we are given the revenue already, that's 1 million, and also the total cost, that's 850,000. These do not have any uncertainty. They are given. We don't have probabilities associated with that. However, we do have some probability associated with this liquidated damage. So we only need to account for the uncertainty that comes from the liquidated damage. That's like a fine, that's a loss that we are subject to if we need more than 95 days to complete, which has some probability associated with it. So we calculate this quantity as 1 million, that's the revenue, minus 850,000, that's the cost, then minus 100,000 times the probability of the project exceeding 95 days to complete. So this quantity, 100,000 times the probability that the T is greater than 95, is the expected value of the liquidated damage. Notice here the total possible quantity of liquidated damage is $100,000. However, this doesn't happen for sure. There's a probability associated with it, so that the expected value or the expected loss from this liquidated damage is this total quantity, 100,000 times the probability associated with it. That's how I got this quantity that represents the expected value. That's 146,000. All right. Now, if the liquidated damage is raised to 500,000, whether we should bid for this project. This answer depends on the expected revenue or the expected profit. So if we derive this quantity from the revenue perspective, we would include 1 million as the for sure total budget. Then we take away the liquidated damage using its expected value. The expectation of, again, is taken using 5,000, that's the total liquidated damage, times the probability associated with it. Again, this probability is 4.1%. This calculated quantity is the revenue minus the expected liquidated damage. If this quantity is greater than the cost, that's 850,000, then of course we should bid for it because our expected profit is greater than 0. We can also use the expected, we can also calculate minus another 850 away from this quantity. And from here, we know that that quantity would be greater than 0. So If the expected profit is greater than 0, that's why we need to bid for this project. Okay, for the last question. This quantity, we're asked about what's the highest amount liquidated damage that the contractor is willing to bid under. We calculate this quantity at the threshold so that expected profit is exactly 0. Any liquidated damage that's above it will give us a negative expected project, and any expected, well, any liquidated damage that's smaller than this quantity would give us a positive expected profit. That's how I derive this quantity as the gross revenue minus the cost. That's 150,000 divided by the probability of T greater than 95. That's 4.1%. And this quantity is huge. So we know that the contractor is willing to accept a very high liquidated damage amount. All right, our lab session is done. Please submit your worksheet here with your name and your partner's name on it.